design. Anyway, he's a fourth year student.
Okay.
And in the lab project, we study about the PV inverter system. And this is some simulation, like how to track the maximum point and his target to apply the MPPT, but for parallel distributed generation.
Okay.
It could be a new trend in the future. MPPT for one distributed is like traditional conventional one, but image that you can connect multi PV in the in parallel, so we can make some journal or something like that. Yes. And this is Yui. Yes, this guy.
Okay.
Yes, he study about permanent magnet, PMS and synchronous motor and PLDC motor. This is PLDC motor, and he tried to show you how he can control the speed.
Okay.
Anyway, this is like speed control for PLDC. Another PMS and motor is maybe he keeping out somewhere. His project is right now is PMS. So PLDC is like much simpler than PMS. This just is a small size motor, but instead for students to make experience.
That's good.
Yes, that's good. And from here we have the group of Professor Phương. Professor Phương mainly focus about IoT device and smart device.
Okay.
For example, this is one of the chip from STM32, and they can communicate wirelessly to the server over internet, and they can collect the data like power, like the light sensor or something to turn on and turn off the light. Yeah, it's belong to the smart city, like that. Yeah, and from here, for example, we open one of the smart communication, like wireless communication.
Okay.
Yeah. And he's from Mr. Hưng. He's a 4-year student. Actually, he's worked very hard, and he have many ideas to apply in the DC island DC microwave system. So for example, in this topic, he study about decentralized consensus by algorithm to achieve the accurate power sharing and DC bus voltage restoration. And this is some simulation. And this is the headband system. DSP, then we connect by cable to some controller board. Actually, you can plug the DSP to here. This is the launch part. You can plug here, and it make decentralized system. Or you can connect like master and slave. This is master and slave to DC. This is buck maybe buck or boost control. And also DC electronic loss and some power. And this is the maximum is 3 kilowatts. And this is some project from graduated master student. He make a three level single phase micro inverter. A micro inverter is maybe the trend in the future. They use 3 level, not 2 level.
Not 2 level.
Yeah, 3 level for inverter. And they can connect to the grid seamlessly. This is
quite impressive.
And this is a project from master lecturer Nguyen. He tried to make a dual active bridge, DAB. Yeah, dual active bridge, and this PCB can also make LLC also, because DAB and LLC are almost same. We can connect the high frequency transformer and capacitor to make the DAB or LC less. Yeah. So in our lab, we focus to make everything as much as simple as possible. So we use the launch pad from the does that instrument, because this kit is very cheap compared to the one that you make by year. If you make the whole board like this, does that instrument, you might cost a lot more than you bought a large part for student. And we just build a high power and signal board. And I'm a designer of this whole PCB. So I'm a designer.
Oh, you design?
Yes.
Oh, okay.
So actually, power electronics is really hard for students to study. Not many students in Korea or in Vietnam have interest in the power system. So to make it simpler, I try to make a roll like this. You can see. So the voltage sensor is like around this side. So students only focus on the input for measurement, right? And output we only connect the power, and we have two signal output for sensor. And this is the op-amp for signal processing. Signal processing means you may differential analyze process the signal from this current sensor from lamp isolated voltage sensor or something. So we need op-amp. So op-amp is kind of hard thing for student. So by doing this, student it's easily for student to think like you may connect the input and you get one output. So not student do not worry about the capacitor or op-amp something. It kind of complicated for new student. So they have to make something work, and they make the whole interesting. That is the target. That's why every part in this board you can see I try to roll something like this. It is like offset voltage. This is like current sensor. So input and one output only. So it make everything simple.
Well, that's a really good idea, I think. It's a make easy for the students.
Yes, and for the gate driver, so if we make the plug and play gate driver, because MOSFET easily damaged during experiment. So we try to make the plug and play, and we use protection, desaturate protection. This is very good to protect the IGBT and MOSFET. I think that is the keys. This one for the MOSFET, we plug it on the bottom to save the space. And you can easily measure the VGS or VDS. If you put on the top, it's really hard to measure everything. And anyway, it's a big because it's an evaluation. So students can easily evaluate and measure. So if I try to make it as compact as possible, it will really hard for students. So after 1 or 2 times burnout, student will get away from the lab. That's true. We also have some like the AC power source, like that one. And these are students from Professor Young. He have many people, and he working about 3 levels. And some modulation technique. He have many conferences.
Gate driver. Gate driver.
This guy study about PFC, power factor correction. And this is the soldering station. So the soldering station actually is smell, and the smell is not good. And nowadays in the Gen Z, Gen Z students don't like something smell. That's why they study AI, they study computer science, because they didn't smell. So we try to make it, we try to filter the air by using one fan in here, and one, how can I say, we have one carbon filter. This is the chipless. I think it make a chipless. Few from smoke absorber. This is a chipless one.
This is a really good idea. I should use this idea, but I borrowed from him. Yeah, it's good. It's good.
Yes. And this student from Professor Tuyên,
Okay.
and this guy is make a 3-level TNBC, 3-level
Okay.
neutral point. Yeah.
Okay.
And this is input line from the PV simulator like that, and the output is a 3-phase.
Oh.
Yeah. We make a reconnecting system.
Yeah.
Try to control the power, the reactive power, compensate the harmonic something.
Okay.
Yeah.
It's not a charger.
Uh,
Charger.
No, it's not too big. And I think that's all for
Wow, it's a lot of things happen here.
He was living in Korea.
6.5 years.
From
Ulsan.
Ulsan.
Yeah.
Ulsan.
Master and PhD.
Oh,
And
okay.
postdoc.
Postdoc.
Postdoc for half year.
Ah, okay.
There are several former PhD students of those
Okay. Professor.
so their experience from Korea now can apply here.
Oh, okay. Yeah. That's
Many service.
That's good. That's good. I know Professor Hong Hee Lee very well. Well, actually, his son.
Yeah.
His son was my graduate student.
Yeah.
So he sent his son
To your lab.
to my lab.
Not in his lab.
That's his lab.
It's not easy to teach.
Yeah. So he is currently he's working in the LG electronics. I mean the Professor Lee's Lee's son.
Yeah.
He's working.
He doesn't want to be a professor.
I think so.
Yeah.
Another professor.
Yeah.
It's quite interesting. Everything is you make a really working full time here. It's quite interesting.
He's working full time now.
Probably.
Working.
I think we have a lot of students who are interested in research in Korea.
Oh,
So
yeah,
if you have any scholarship or grant, I think you can give me some information so I can introduce you some smart working student. For
Yeah.
example, this guy he already actually he's smart enough to join the medical. I mean, he can be a doctor,
Okay.
but he deny and join the engineer major in university.
Why did you do?
You mean medical doctor?
Doctor.
Doctor?
It's great in the final exam, the university exam. His grade is very high, but he did not apply for a doctor.
Okay. Wow. He's a very good student, I think.
Yeah.
Yeah.
He's
Oh, yeah.
I think he can write the paper very well.
Yeah.
So,
So if you have any suggestion, then I will support him.
yes.
Yeah, I will support him. Yeah. Well, actually, I have many projects, but I don't have the student, so I cannot get more projects. So I need to hire more students to. So it has a lot of opportunity in my lab. Okay, so anyone.
Young, excellent professor.
Yeah, no.
I think it is my pleasure to introduce some of students that I know they are hardworking and they are good in writing something. But he's the third year student. I
Okay.
mean, he need 1 more year to complete the
Absolutely.
the program course in the university. Then after maybe
Automation.
1.5 year, depend on the program of the
Okay.
university. We graduate 1 year later.
Okay.
Is the major in automation or
No,
power engineering?
Power electronic.
Power engineering.
Yeah, power engineering.
Okay,
Yeah, good chance.
Yeah, just
Also, Ron, I think Ron is also good. This guy is really smart.
okay. So if you suggest, then
I also invited him tomorrow.
that's right.
Meeting.
Okay,
And then at the dinner together.
Okay, that's cool. So I will show my research work in a little bit detail. So I don't have time today, but tomorrow
Okay.
I will.
Tomorrow, big meeting.
Yeah, thank you. Also, you can visit my lab if you have any chance. We already have an MOU,
Yeah.
so exchange the professor and the researcher.
Yeah.
So I can invite you and of course him. I can invite one or two persons.
Yeah.
So visit my lab and my university and the other institute of Korea.
Yeah. Thank you.
Yeah.
Thank you, Ron.
Thank you very much.
Yeah.
Thank you.
Yeah.
Thank you.
Yeah.
Thank you.
Yeah, thank you so much, bro. Thank you.